Hey everybody. I am going to be talking to you guys about iron. And specifically, I'm going to be talking to you about the forms of iron and the role of iron as kind of a dietary supplement. You can see this PowerPoint is up on your Canvas page, and I've also got the presentation saved as a PDF up there. Um, but with, I guess, nothing else to lead in on, which, uh, before I include that thought, we've got vitamins and then a review next week. And then we've got exam number 4 on Tuesday, the 19th of November. So at any rate, well, let's go ahead and get started. So iron is seen on the periodic table with the elemental symbol Fe. Now, typically, whenever I think of iron, I always think of British rock band Iron Maiden. And I just decided to throw this in there because, Iron Maiden rocks. So, at any rate, iron is a dietary supplement, and it can be taken as a dietary supplement. More than anything else, iron is essential for basically, you know, your own general health. There's in the event that you do not have a lot of iron in your body, you could suffer from anemia. Um, so, and that's going to make you feel really tired, and it's going to basically reduce the amount of oxygen that kind of goes from your lungs to other parts of your body. Iron is an essential mineral. It is, it plays a critical role in blood health. And when you have an iron deficiency, it is a nutrition problem. Now, iron as a dietary supplement, it comes in kind of two different forms. Those two different forms are a heme and a non-heme form. Okay, you might be thinking, what on earth is a heme form and what is the non-heme form? Okay. Well, to give you a little bit of context for that, I want to show you this protein right here, or this kind of thing that looks like a big curly Q or a series of curly Qs. This is a protein known as hemoglobin. That is a critical protein for basically getting oxygen around your body. When you inhale air, which your air is about, I think it's something like 30% oxygen. There's N2, there's carbon dioxide, there's carbon monoxide, there's a bunch of other stuff in there. O2 is what we want. And, you're not in a 100% oxygen environment, but at any rate. So this protein right here is the protein that basically transports that transports oxygen through your bloodstream. So from your lungs to your fingers to the tips of your toes and everything like that. Now, I want to draw your attention to something else, and that would be, and I'm going to switch to, I think, a black, and I'm going to highlight this thing right here. I'm going to draw a couple of boxes around it. This kind of greenish structure. It's right here. It's right here. And there's one last one way back here. So that greenish structure is a molecule known as heme. That's actually the molecule that is also pictured below, right here. So heme is the molecule that hemoglobin uses to bind oxygen. And there are, like I said, two different forms of iron. One is as this heme form, which we can see in the middle of that heme ring, this guy right here. This is iron 2 plus. Okay. So iron 2 plus is an ion of iron, and that is the form of iron that's really good at getting oxygen around your body. Now, whenever we think about iron and its role in getting oxygen around the body, it has to be associated with this heme molecule. And that heme has to be associated with this hemoglobin protein. So I kind of want to give you that context. Now, one thing is that an iron deficiency can lead to anemia. And approximately 1/4 of the world suffers from anemia. And that's just a matter of, well, they don't have enough iron in their diet. And I think that the first time I ever heard about heme versus non-heme iron was really in the context of I had a friend who was a vegetarian and therefore they didn't eat any animal or they didn't eat any meat or anything like that. So red meat was out of the question for them. Well, what that meant is that they would not get quite as much heme iron because in like a steak or something like that, that steak is going to have, just as you know, our blood and our muscles have hemoglobin, so too do cows' bloods and muscles. And so if you eat a steak, you're going to get hemoglobin, and therefore you're going to get heme, and then adding onto that, you're going to get iron from that. So if you eat a steak, you're getting iron through this kind of mechanism. Now, if you never eat a steak or never eat any sort of animal muscle or anything like that, well, then you're not going to get that source. Now, there are other sources of iron. Um, for instance, spinach is always a good vegetable that has a lot of iron, but the difference is that that spinach is not going to have the heme form. It's going to have a non-heme iron, which that non-heme iron is kind of notorious for not being absorbed quite as well. So that's those are kind of the barriers that you're up against from like the necessity of iron. And so as a result of this, it's pretty common for someone to, take an iron supplement and basically get enough iron into their diet by using like a capsule or a pill or something like that. Now, what are the roles that iron plays within the body? And this is just to kind of double down on what we saw previously. Well, it functions in the body by transporting oxygen from the lungs right here. You pick up oxygen, and this hemoglobin forms what's known as oxyhemoglobin. It takes four oxygen molecules and then deposits them in like muscle tissue. So that oxygen is dropped off. That oxygen is going to go to this structure right here, which, if you ever took like a high school biology class or maybe even a college biology class, this little lima bean shaped structure is, I feel like if you're hearing this and you're looking at that, you might very well be saying the powerhouse of the cell. That's the mitochondria. That's the powerhouse of the cell or of a eukaryotic cell. And it loves to have oxygen because that is how it can break down sugars and get a lot of energy. So hemoglobin takes oxygen basically from the atmosphere into the lungs and drops it off in the tissues. And then hemoglobin transports back to the lungs so that it can pick up more. It also deposits um, carbon dioxide in the process. Now, all of that ability and all of that capacity that hemoglobin and arguably, yeah, that hemoglobin has is because of iron. If iron were not there, hemoglobin would not be able to do this. And that's a pretty important part of all of this. Yeah, hemoglobin's important, but if hemoglobin doesn't have heme and it doesn't have iron, then it's really kind of useless because hemoglobin itself can't pick up an oxygen and move it. Instead, hemoglobin needs heme, and that heme needs an iron ion in order to do that. So, iron is essential for oxygen transport, to put it simply. Now, heme is, or so iron's role in energy production, really where it goes is since it's involved in the mitochondria, it's going to be found way down here and a little bit over here, the citric acid cycle. So iron's role in energy production is in the citric acid cycle and oxidative phosphorylation because that's where oxygen is going to be used. Now, with that in mind, here's a kind of specific example of where that oxygen is kind of involved. And I'd like you to just look down in the lower right-hand corner right here, O2. That O2 right there is basically brought to the cell by iron. Now, I don't want you to be overwhelmed by the details in this, but this is just where within the mitochondria in what's called the mitochondrial matrix, kind of the interior, the guts of the mitochondria, that's where oxygen is going to be involved. And that oxygen is going to be, well, it's going to be producing water and it's going to ultimately be producing a bunch of ATP. In addition to that, these things that I've highlighted here, these are molecules known as cytochromes. And these molecules are, well, they all have an iron ion. And by having that iron, they're able to do what's called electron transport. And that's going to lead to the production of a bunch of energy. So, iron, what I want you to think about, like kind of the roles of iron, and I'll type it at the bottom of the screen here roles of iron. I'm going to tab over oxygen transport and electron transport. Those are the two major functions that I want you to know about for what iron does. It's involved in oxygen transport, like kind of from the lungs to the tissue, and then within the tissue, electron transport. Now, with that said, sorry, let me clear my drawings here. In the event that somebody has an iron deficiency, well, what could this lead to? One thing is that if you have an iron deficiency anemia, well, chances are that you're going to run into some problems. And these things are going to kind of manifest themselves. Like your symptoms of iron deficiency anemia might vary a little bit. You might, have a lot of weakness. Maybe if you're like a highly active, like weightlifting person, you might not be able to lift as much. You might also have some pretty extreme fatigue, like bordering on, falling asleep while you're talking to someone. You might have shortness of breath. You might have a nasty headache or some dizziness. And these are kind of like acute, I apologize, um, acute symptoms of iron deficiency anemia. Now, in order to like causes of this iron deficiency anemia is if you suffer some sort of injury where you lose a lot of blood. Um, when you lose that blood, you lose iron as well. You might also have an insufficient dietary intake. Now, this is the example that most vegetarians kind of encounter because their dietary intake of iron is a little bit lower because meats have a lot of iron in them. And typically, if someone's like, well, I'm going to eat a 16-ounce steak, that might not be a crazy kind of proclamation or decision, but a 16-ounce, I'm going to eat 16 ounces of spinach. Okay, well, you might not eat 16 ounces of spinach. In addition to that, most vegetables and like red meats, it's not a one, like 16 ounces of, let's say 16 ounces of cauliflower and 16 ounces of steak are not going to have the same amount of iron. So you're not looking at it's not 16 for 16. Instead, you're looking at it as, okay, well, if I want to get the enough iron from cauliflower that I would get from 16 ounces of steak, well, it sounds like I better eat, 80 ounces of cauliflower. So that's one of the problems that people encounter. In addition to that, people who are pregnant can experience some sort of iron deficiency because, well, they've kind of got something that's taking a lot of their iron. And fetus, like baby in utero, a fetus as it's developing, it's going to be kind of siphoning off resources that the pregnant person has, that the mother has. Then also some people suffer from what are known as malabsorption issues. So they might consume enough iron, but it doesn't actually get absorbed completely, or they might absorb only 50% of it. Now, some good dietary sources of iron. Well, first of all, we got to go back to that heme iron. So heme iron comes from plants sometimes, animal sources, and iron fortified foods. Good sources and your typical sources are like red meat, liver, beets, broccoli, I think spinach, your green leafy. I always want to say greeny leaf. But your green leafy vegetables are good. Um, Now, when it comes to our different forms of iron, your heme iron easily is absorbed and is the type from animal sources. Your non-heme iron is not nearly as well absorbed, and the type is from plant sources. So your non-heme iron is coming from plant sources, whereas your heme iron is typically coming from animal sources. Now, when it comes to recommended daily allowances by you know, the World Health Organization or the Food and Drug Administration. These are numbers that are agreed upon by professionals who, they understand physiology, they understand basically, general health for people. And typically, what is required is for most adults, and I'm just going to go ahead and use a big group here, adults from 19 to beyond. Well, adult males need about 8 milligrams, maybe a little bit more. Females, well, they need 18 milligrams, and up until they're about 50. Um, and at that point, then they might not need quite as much iron. So this is a little bit of a range. Now, with that said, there are like ideal amounts, and there's the recommended daily allowance, but also you have upper limits. Now, when it comes to iron, one of the important things to understand is that there's I guess, a property of iron known as bioavailability. Now, essentially, bioavailability is um, the amount that can be absorbed. So if we look at this, this is from a paper. This is a scientific journal article that is. So I bring this paper up because of the fact that what this paper from the journal Nutrients in 2019 analyzed was heme and non-heme iron intake in iron dietary sources in adolescent menstruating females in a national Polish sample. Now, one thing that's worth noting is that this is not like a Polish sample as a special type of sample. Instead, this is a sample of this population in Poland. So it's definitely like a very narrow focus, but the authors are from Poland, so it makes sense. Now, I bring this paper up because within this paper, it provides some information. Heme iron, it references heme iron right here, and says that it's highly bioavailable. And so, what that means is that 25 to 30% of this is absorbed by the body. So, what that means is that if you eat a steak that has 100 milligrams of iron, well, 25 to 30% of that iron, so 25 to 30 milligrams of that iron is going to be absorbed by your body. Now, alternatively, okay, so I'm going to switch colors so I can highlight it in a different fashion. Non-heme iron, well, its bioavailability is different, and only about 1 to 10% of it is going to be absorbed. So you think about that as if you have a very, I guess, a highly bioavailable source of a non-heme iron, 10% of that would be absorbed by the body. So now I can give you some comparisons. So let's say heme iron, 100 milligrams, and let's say 30%. We'll just be, kind of a nice round number and say 30 milligrams will be absorbed. Non-heme iron. if you eat, if you wanted to get 30 milligrams, to get 30 milligrams, you need to eat, well, let's see. If it's, let's say that it's 10% bioavailable, if you want to get that same amount of iron, that means you're going to have to eat, well, 3 times as much. And that requires you to make a really big assumption that it's going to be highly bioavailable. Now, that just is an important discrepancy when it comes to like your dietary selection and getting iron into your diet. Now, with that said, I wanted to share with you basically some differences between um, iron sources. And so I made this table that you're going to see in just a second. Um, Here are different sources of iron and basically their bioavailability or the percentage that's absorbed. So if you look at this table, a cooked steak, well, about, you know, 25% of that's going to be absorbed. That, that aligns with what we saw here, 25 to 30%. So roughly 25%. Um, but if you eat in these quantities are coming from eating or consuming 100 grams of this particular thing. So what that means is that if you eat a steak and you eat 100 grams of it, you're going to get 2.7 milligrams of steak, or sorry, 2.7 milligrams of iron. If um and so when you think about that calculation, well, of the 2.7 milligrams that is in that steak, only about 25% of it is going to be absorbed. So that means you're talking about, I don't know, probably 0.65 milligrams from one steak, that or one 100-gram steak. Now, if we look at all our other sources, and one thing that I'd like to mention is that this does not distinguish between a heme iron source or a non-heme iron source. This is simply looking at what the source or what the food is, the amount that is present per 100 grams, and then what is the absorption rate of that. Dark chocolate, for example, well, 11.9 milligrams of dark chocolate in 100 grams. So if you're presented with, well, are you going to eat a steak or eat a dark chocolate Hershey's bar? Well, if you want iron, then you probably actually want to go towards that dark chocolate. Now, what's worth noting is that the absorption rate is considerably lower. It's 15% for dark chocolate compared to that steak. And that has to do with, well, what is the source? Is it a heme or non-heme source? But if you eat 100 grams of dark chocolate bar, you're going to get more iron absorbed by your body than if you eat 100 grams of a steak. Now, with that in mind, I'm going to clear my drawings out here. I wanted to go ahead and kind of cycle through a couple of different iron supplements in just a moment, but I wanted to introduce kind of a general iron supplement. Now, here's an example of, if you just do an Amazon search for um, iron, well, you're going to find something like this. This is plant iron. So if you can imagine that this is a plant iron, it is the non-heme supplement or non-heme form. 25 milligrams of iron in a capsule. Now, I can almost guarantee you that capsule is probably 1 gram, between 500 milligrams and a gram. Now, there are some potential side effects of iron supplements. Sometimes they cause constipation, they cause nausea, they cause hemochromatosis, which is a condition that can result if your body absorbs too much iron. Now, that is there's a genetic condition known as hemochromatosis. But also, whenever you're taking, well, an iron supplement or, kind of any supplement for that matter, it's important to understand how much you're actually ingesting and how much is too much. If let's say that you start your day with, you know, two big pieces of dark chocolate and then, a steak in the morning, a steak in the afternoon, and a steak in the evening, you probably don't need to take an iron supplement. Now, the upper limit or the upper intake limit for iron is approximately 45 milligrams a day. Now, that's not It doesn't seem like such a huge amount, especially when you look at something like this. This is a supplement that has 25 milligrams of iron. Now, an important thing to remember is all of that iron going to be absorbed? Nope, it's not. Only a small percentage of it is. Now, but that's really echoing the idea that if you have a, if you're eating a lot of red meat and eating a lot of dark chocolate, you probably do not need an iron supplement. If you're eating a vegetarian diet and not adding any sort of dark chocolate to it, then you might need to add an iron supplement. Now, here we go. With respect to um, excess iron, what can that cause? If you have like an acute um, iron exposure, so let's say that let's say you just weren't paying attention and you were like, oh, I'm feeling a little tired, and maybe I have some, you do some sort of like WebMD self-diagnosis, and you're like, oh, I better take an iron supplement. And let's say that someone, you see a friend has an iron supplement, and you say, hey, what's the serving? They say three, three capsules. And if you accidentally hear 33, and then you're like, ooh, well, I better take 33 capsules. Well, then you're gonna, run into a problem because you're taking 11 times as much as you need. That would be an example where you can have an acute, I wouldn't describe it as poisoning, but you'd have an acute exposure to iron. Now, that can lead you to throw up a bunch. It can cause diarrhea. It can even cause organ damage or death. Now, if you are kind of suffering from or experiencing more chronic upper intake level exposure or upper limit, well, then you're more prone to liver damage or heart disease or maybe even joint pain. So basically, you've got two major types of excess, whether it's acute, it kind of happens like on one random day, or it's chronic. It's something where you've been taking an iron supplement and eating steaks every day for 20 years. Then you could cause some long-term liver damage. Now, hemochromatosis is a genetic disorder that really causes your body to absorb too much iron. Now, that excess iron ends up stored in your liver, heart, and in your pancreas. The treatment for this is to remove blood from your body. Now, I remember years and years ago hearing this story about a guy who I believe that this was the case. I think that this was the condition that he had. Um, he was a season ticket holder for the Green Bay Packers. And the Green Bay Packers season tickets are like notoriously difficult to get. They're something that people pass down in their wills, um, just because, and it's like this has to stay in the family because if it doesn't, there's a waiting list that has 75,000 people on it. At any rate, this fellow was a Green Bay Packers ticket holder. And if I remember the story correctly, it was something like every Friday or every week, he would always go and either donate blood or donate plasma or something like that. And effectively, when you remove an amount of blood from your body, you've removed iron from your body. And by doing this, like every day, or not every day, but like every week, effectively, he was removing kind of this excess accumulation of iron from his body. And so that had he not been doing that, then he could have gone on to experience some sort of liver damage. Now, the significance and how it relates to the Green Bay Packers was that he was having this blood removed because I think it must have been plasma. I think that he was donating his plasma or not donating, but selling his plasma. And so he would get, $50 or whatever for donating his plasma. And that was how he paid for the tickets. So that's how it brings it to the Packers related story. But this was an instance, and I'm like 95% sure this was the condition. Um, but for most people, blood loss is kind of a bad thing. because he can lead to anemia. But for this guy, he had so much iron in his body anyway that that blood loss is actually kind of protecting him a little bit. Now, how is iron absorbed in the body? What I'd like to draw your attention to is at the top of the screen here. It's kind of blocked off, but we've got this right here. This is known as your intestinal lumen. So think about this as what I just highlighted as basically your gut, and then the bottom half of it is your bloodstream. In the middle, this white space with kind of a curly Q Bart Simpson haircut, um, that is going to be what's known as an endothelial cell. So that's the type of cell that basically separates, the interior of your gut from your bloodstream. And what this is really just showing is that uh, the process by which iron goes from the intestinal lumen into the bloodstream. Now, what I want to highlight here and kind of the yeah, the focal point is look at these three right here. Those three things are heme with an iron in the middle of it. And let's watch, and I'm going to draw a little box to show the path that that heme iron goes through to get to your bloodstream. HCP1, that's called a transport protein, and that's a protein that's found on the like surface of the cell. It binds heme. HCP1 is the heme carrier protein 1. It grabs onto that heme and says, okay, well, I'm going to bring you into the cell. Brings you into the cell. And then it goes to this FLVCR. That's also a transport protein. And if you look, I'd like to draw your attention here and here. Now, in this first right here, what we've got is we got kind of a straight path. That heme, once it gets into the cell, goes straight to that transport protein, and boom, it's in the bloodstream. Now, the significance of this is I was talking about heme and non-heme and their difference in absorption. Well, your heme iron, it's ready to go into the bloodstream. Your non-heme iron, it has a little bit more of a, I wouldn't say a murky path, but these three green balls there, those are your non-heme iron. And when they get transported into the cell, there's got to be some sort of reaction that's done to them so that then they can be transported into the bloodstream. And so it's like, it's just a little bit less ready to be used. And so as a result, that non-heme iron, I wouldn't say that it causes problems, but it's just a less direct way being able to use iron. So your heme iron kind of has that preference because it's almost like it hits the ground running. Now, it's fair to ask, as a nutritional or as a dietary supplement, is there a population that needs to make sure that they're getting enough iron? And the answer is yes. Pregnant women, children, vegetarians, athletes are all populations of people who might want to consider, of course, in consultation with a physician, might want to consider like taking an iron supplement. Do they have enough iron? Do they just need to change their diet? That's a fair question. Um, Children, I think a good reason that they are included in this list is kids like candy, bubblegum, and taffy, any type. They like candy and they don't like steak. They don't like vegetables. They don't like dark chocolate. You can make the case that dark chocolate is a candy. You could also make the case that dark chocolate is not a candy. Um, so when you think about what a kid is consuming day to day, they might not have a lot of good iron sources. So that might be something that, you know, of course, with consultation with their physicians or their pediatrician, should they take it? Pregnant women, vegetarians, athletes, these are all populations who, well, they're either working very hard or maybe the amount of iron that they're ingesting isn't enough for what their body currently demands. People who are pregnant, well, they've got something growing inside of them that's using half of their resources. And so, do they have enough iron? Are they bringing in enough iron for both them and that person who's living with them? Maybe, maybe not. Um, and then vegetarians, again, do they have enough rich iron sources in their diet that will kind of put them over the edge to get enough? Now, athletes are kind of an interesting population because, well, higher iron level means increased red blood cell production. And this is needed to enable oxygen transport to tissues. Iron is sometimes lost through your sweat, so working out and in a hot climate might be even more depleted. And then this is one that is, I think that it's fair to say that it's maybe uncertain, is a phenomenon known as foot streak hemolysis. So, what this affliction or what this is suggesting is that, if you're a distance runner and your feet are hitting the ground, hitting the ground, hitting the ground, hitting the ground, you're basically like bruising your feet constantly. And what you're doing is you're reducing red blood cells because that constant foot strike is damaging those red blood cells on the bottom of your feet. Now, what's complicated about iron is, and this is like if you go to the grocery store and you're like, oh, I need an iron supplement. Heck, any dietary supplement for that matter. If you go in, you're like, I need a supplement. Ooh, what do I get? And sometimes people will find the ones that will just have like the branding is very influential. You might see like iron for men and be like, well, that's what I need. Or iron for women. Oh, well, that's what I need. Is there anything different about those two? Probably not. It's probably just the packaging. Maybe there's something else added to the men's or women's formulation, but in terms of do women do women need non-heme iron versus heme iron? No. Iron's iron. If it's not an ion, then it's a different story. But here what we have are a total of eight very common iron supplements. You have iron or ferrous sulfate, ferrous gluconate, ferrous fumarate, heme iron polypeptide, ferric iron, carbonyl iron, polysaccharide iron complex, and liposomal iron. I want to go through all of these and give you a sense of what distinguishes them from one another and what's their story really. So ferrous sulfate is the first one on the list, and this is commonly and easily available. This is something that you're definitely going to find at the grocery store. One drawback is it can cause GI or gastrointestinal issues. Approximately 10 to 15% of it is absorbed, so 10 to 15% bioavailability. Ferrous gluconate. I apologize. Ferrous gluconate is another type of iron that it has a lower absorption rate of between 7 and 10%. Now, this will partially because of what it's associated with, gluconate as opposed to sulfate, and its absorption rate. This is an example of an iron supplement that is less likely to cause gastrointestinal issues. Ferrous fumarate, well, 10 to 15% absorption, and it's similar in function to ferrous sulfate, so can cause GI issues, and despite that, it's pretty easily available. Heme iron polypeptide. Okay, so this is the first example of an iron supplement that looks like it has heme with it. These other ones were your ferrous sulfate, ferrous gluconate, ferrous fumarate. Those are all non-heme irons, which is why they all had lower absorption percentages. Heme iron polypeptide, 15 to 35% absorbed. Generally, this is going to be a little bit more expensive than those previous ones. And the reason is because, well, these are extracted from, animal meat or blood. This will, however, despite the high absorption rate, lead to fewer GI issues. Ferric iron, also known as iron bisglycinate or your gentle iron, well, this has a low incidence of GI issues and it's a low absorption rate. Carbonyl iron, low absorber, and it's also as a low absorber, um, folks will use it for its kind of slow release effects. So basically, well, I can take this capsule and it's going to be giving me, a small amount of iron throughout the course of the entire day when it's being consumed and processed. Polysaccharide iron complex. Now, this is one thing that it's kind of a critique or criticism that I have of dietary supplements. If you have, let's say that you have been to the doctor, you go get your annual physical or something like that, but your background is not in chemistry. And you see something, and let's say physical, and your physician says, "Hey, you need to take some." A fair question is what kind? But let's say you forgot to answer that or you ask that question. Um, and then you go to the grocery store and you look around, and you're like, oh, ooh, carbonyl iron, gentle iron, proferrin, clear. Is that even iron? I don't know. Oh, it says heme iron, polypeptide. These are all substances that are all dietary supplements that, man, there's like very technical jargon associated with them. And if you don't ask that question of your physician, like, what kind should I get? You might get the wrong one, in which case you might as well have not even gotten one sometimes. So this polysaccharide iron complex, which just as a little bit of an aside, a polysaccharide is a sugar. So this is kind of like sugar iron complex. Well, 30 to 40% is going to be absorbed. It has a slow release pace and low risk of GI issues. Last, I think the last one that I wanted to highlight here, or maybe yeah, kind of the most important one is liposomal iron. Now, a liposome is an interesting molecule because it's almost like you could kind of think about it like a molecular envelope. Um, and I mentioned that just because most cells, if they're handed an envelope, to use that analogy, that metaphor, they're going to be like, oh, great, I see an envelope. I'm going to take that envelope and I'm going to open up what's ever in that envelope. Oh, it's iron. Okay. Um, I want to distinguish that from all of these other forms of iron. What are they relying on to get into the cell? Well, they're relying on a transport protein, like what we saw right here. Um, but those transport proteins, they have some limitations. So that transport protein helps iron get into the cell. Liposomes are kind of like an envelope that help iron get into the cell, and they help other things get into the cell. But the significance of that is liposomal iron has about 90 to 95% absorption. So, what that means from a math perspective is if you take a 100 milligram pill, you're getting about 90 to 95 milligrams of iron into your cell. If you compare that to, go back for a second, this right here, this is a high absorber. Let's say you take one capsule of this, and that's 100 grams, you're getting about 30 to 40 grams of it. So, in order to match up with this, for that polysaccharide iron complex, you would have to take about three of those pills in order to match this. Now, liposomes, like I said, they're nice like envelopes. They package the iron or they package whatever molecule into them, and then they go to a cell, bind onto it, and boom, whatever they were carrying inside of them is now inside the cell. Now, with that, there are some substances that are iron absorption enhancers. Vitamin C is an example of a iron absorption enhancer. Um, so vitamin C can uh, help your cells by making Fe2 plus. So iron has a couple of different kind of charges to it. It could be Fe3 plus or Fe2 plus or Fe1 plus or Fe. And I think there are some other oxidation states, but that Fe3 plus, that's kind of not extremely useful. So in order to make that a useful form of iron, well, then you need to convert it to that Fe2 plus. There are some organic acids, citric acid and lactic acid, that can help non-heme iron remain soluble. And fructose, the sugar, is also a helper of absorption. Now, there are, however, some compounds that are iron absorption blockers. Phytates, for example. These are compounds that are found in a number of different cereal crops and grains, legumes, seeds, and nuts, and they bind iron and make insoluble complexes. So they will bind iron and basically just take it out of circulation in some respects. Calcium, Ca2 plus, calcium ion competes with iron for absorption in the gut, which makes me think they're probably using similar proteins for this. Polyphenols, which are compounds found in tea, they are also found in vegetables and red wine. And then last but not least are oxalates. Oxalic acid is the most common of your oxalates. They can bind to iron and reduce its bioavailability. So essentially, these different molecules um, are presenting problems in the processing of iron. Um, so these are some of the blockers. Oh, and then here are some of the kind of enablers, I guess, the enhancers. Um, Now, in terms of things that I want you to kind of be familiar with, well, I want you to not know these exact numbers, but know the significance of them. And I think the easiest thing that you can do is to say, all right, well, if I had to take 1 gram of iron, which one would I pick and how much would it be? So let's just go ahead and, you know, think about a couple of these different options. So let's go ahead and say, and actually, I'm going to give myself a blank slide to work with. New slide. There we go. Go back to this. There we go. Okay. So let's say I need to take 55 milligrams of iron. Oh, but wait. You know what? That's right here. 45 milligrams a day. So if I've decided out of nowhere, I'm going to take 55 milligrams of iron, well, then I should probably talk to my doctor about that. Because that puts you at the upper limit. Now, going back here, let's say, however, that's the amount that we need. The thing is that the amount that we need absorbed, or is that the amount that you know, we need in our body? Or sorry, or we just need to take? And the answer is this is probably the amount absorbed. Because why would you not need it absorbed? Now, with that in mind, I want to use a couple of percentages. We're going to compare liposomal iron and this polysaccharide iron. So let's say that this is what I need, 55 milligrams. Then I'm going to say PS or polysaccharide iron, Fe. And then I'm also going to mention my with our um, polysaccharide, we're talking about something that's 30 to 40%. Let's give it a generous 40%. 40% absorbed. Liposomal iron, I'm going to give that also 95% absorbed. Now, for this right here, this bottle of liposomal iron says 25 milligrams. So I'll just say serving. Or I'll go with capsule. Not serving, not capsule. I'm going to instead go with yeah, serving size actually. The serving size of this are liposomal iron, 25 milligrams. Okay. Um, this would be our polysaccharide iron. Actually, you know what? That doesn't list the amount. So I'm going to go with this guy right here. No, let's go with ferrous fumarate, 10 to 15%, 18 milligrams per capsule. Okay, I think I go with uh, my percentage here, 10 to 15%. I'll go with 15%. And the capsule there said 18 milligrams. Okay, so 18 milligrams. Now, I think that a very good question to ask here is, well, let's say that we're going to try to get all of our iron from these supplements, and we're just going to ignore our diet. Well, 18 milligrams. Okay, so essentially what I want to do is say, you know, number of capsules, CAPS, for serving. Okay, the number of capsules for serving. Well, 18 milligrams. Let's do 55 divided by 18. Okay, so that's looking like 3. Now I need to take 3 capsules of this, of that 18 milligrams. Um, in addition to that, actually, let me change this up for a second. Only about 15% of that 18 milligrams is going to work. So I'm going to change this. I'm going to say the amount absorbed. Okay, so what I instead need to do is say 15 times 18. Well, 0.15 times 18. The reasoning is that is going to be considering the percentage that's absorbed, 15%. 15% of those 18 milligrams. So the amount absorbed, if you take a calculator, you say, all right, 18 times 0.15, you will get 2.7. So now this brings up a new piece of math. Number capsules to take. Okay, so for this, what I'm going to do is now I'm going to get my 55, the amount that I need to take, and divide that by the amount that was absorbed, which was 2.7. 55 by 2.7, 20, 20.37. Okay, so if you're doing this every day, there are 20 capsules. This is the bottle that you bought. Okay, how many capsules are there? 60. How long will this bottle last if you are taking it as kind of as the math shows? 3 days. It's going to get very expensive. Now, if we were to look at liposomal iron, you've got a serving that's 25 milligrams. Let's do 25 times 0.95. So approximately 95% of the iron gets absorbed. So we're looking at 23.75. So of the 25 milligrams, 23.75 were actually absorbed. Okay, so now what we've got is, well, erase this, and I'm going to say, well, 55 is our target, divided by 23.75. 55 divided by 23.75, that gets us 2.31. So essentially, if we need to get that much iron, do we want to use ferrous fumarate? No, we don't. Because we don't want to be taking 20 capsules or 20 pills just to get our liver to function properly. And just to, you know, basically get iron to every place that it needs in our body. That would be way, way, way too much to take in a single day. Okay, so in terms of cost, I mean, right here, new bottle every fourth day. That's what you'd be doing. Whereas this other one, this liposomal iron, well, that's going to get it. That's going to get it pretty quickly. Now, with that in mind, um, it's important to go back to, well, how much do I actually need? Because if you are trying to get 55 milligrams of iron, you might be bordering on the upper intake level. So that's something that you absolutely need to be considerate of because of the fact that the, like, yeah, this is just, you have to be aware of what you're taking so that you have a sense of, okay, well, I've taken too much or I don't need to take any. So that's what I got. I hope this was helpful and I hope that you have a great day and I will see you on Tuesday. Um, if you have any questions about anything, email me and let's set up some time for Zoom office hours. All right, folks. I hope you guys have a good one.